All right, so this is lesson 3, outliers. So we start off by calculating the mean for boys and girls for shoe sizes. So you'd add the numbers up, divide by how many there are for both boys and girls. Now what I'm going to do is do that by using Python. So students practice doing that with by hand, and then compare your answer to what you got when you did this with Python. Again, you need to make sure that you're in practice using statistics by hand. So I'm going to mount my drive first, and then I'm going to import the library after this cell finishes running. So I'm going to import the pandas library as PD, the NumPy library as NP, and the Seaborn library as SNS. The next thing I'm going to do is copy the path to my file here for lesson 3 outliers. So that is right here. But what I need to do is inside of the Python notebook, go to my drive, and then go to the folder that it's stored in. So here is conditional one variable statistics with Python. And then this is in lesson 3 outliers. And I want the path to this file. So I just click copy path, move that there. And then you just paste it into here. So your path again will be different. You got to make sure you're copying the correct path. It could be in your download folder. And then I just use the head folder or the head file on L3 data to print off the first few columns of each of this data, or the first 5. So now what I'm going to do is group this function by shoe size and gender, and then find the descriptive statistics. So I did shoe equals L3 data of shoe size and gender. So I just did the shoe size and gender columns. And then I grouped it. So shoe dot group by and then gender. And then I did the descriptive statistics. So if you look for boys, the mean is 8.55. And then the minimum is 4. The median is 9. And the maximum shoe size was 13. For girls, there were 17 entries. The mean is 8.75. The minimum shoe size is 3, median was 7. But if you look, the maximum is 30. So unless somebody has really big feet, there's probably an error here. So then when you create a box plot of this, you can go SNX box plot of y equals shoe size of gender. So that is what is on the y-axis, and then x is shoe size. So it just shows you here in the girls box plot, you see we have 2 outliers that are displayed by these dots outside of the maximum. And then the boys, there were no outliers. So if you look here, the 5 number statistics you would just put there, or the 5 number summaries, put there. And then here, task 2 was just making those. And then you can calculate what is an outlier by hand by going Q1 minus 1.5 times the interquartile range, and Q3 plus 1.5 times the interquartile range. And then calculate the outliers or find them. So what you do for task 2, I defined the quartiles as 6.59, and then the interquartile range. So this was the boys Q1, boys Q3, which was 9 and 6.5. And then the interquartile range was 9 minus 6.5. So the lower outliers are B1 minus 1.5 times BIQR. So the lower outlier, any number behind or below 2.75 is a lower outlier. And then the upper outlier is the boys' third quartile plus 1.5 times interquartile range. And then I just printed that out. So anything above 12.75. So you would just scan for any number above or below that. And then you could do the same thing with the girls one. So if you look here, that was for the boys' data. You're going to actually do that by hand for the girls' data. So now what we're going to do is replace that outlier of, or the one that is supposed to be indexed at 0. So we're going to look at shoe at 0 of shoe size, and it was 30. Now we're going to know that that is actually supposed to be 10. So we're going to go shoe dot at of 0 and replace it with 10. And then actually, if we would take that shoe of 0, we can actually point that out. So I can copy this again if I want to see, well, did that actually put 10 in there? I can make a new code cell and put that in and see, oh, all right, that actually replaced it. So now what we're going to do is find the statistics again. So we're going to do shoe group by gender and do the descriptive statistics. And this time we see that boys on average have a larger shoe size with the mean and the median as well. The median shoe size is 9 for boys and 7 for girls. And then the maximums are both 13, probably as it should be. So if we create a box plot now, there's only one outlier for girls at 13, and that's probably just a girl who has bigger feet compared to the other girls. And then there's still no outliers for boys. So in finding the practice problem, so we would find the means and medians and modes. So here we take this, are there any outliers? What height do you have to be shorter or taller than for those? So what we would do for our practice problems, we can first find the descriptive statistics of this height column and group it by gender. And then in looking at these, we can find the interquartile range for boys and girls. So first, if we look by outliers, we actually could create a box plot to see, well, are there outliers? So when I do an SNS box plot of y as the height column of gender, so the gender is going to go here, and the x variable is the actual height of the actual column for height. So this is the gender column is on the y-axis and the height column. I noticed for girls there are actually 3 outliers. So there are outliers to the right and outliers to the left. So to do this, what we can do is put in our girls' first quartile, third quartile, and then the range 62 minus 58, and then find the lower limit, which is for an outlier, which would be 58 minus 1.5 times the girls' interquartile range. So anything below 52 is an outlier. You notice there was one that was below 52. That's why that's flagged as an outlier. And then similarly for the upper limit, I go the girls' third quartile plus 1.5 times the girls' interquartile range. And the upper limit is anything above 68. And again, when I go back up here, this value is, these two values are above 68, which is why they're getting flagged as outliers. So what we're going to do next is look at the check for understanding. So in this check for understanding, what you're going to do is calculate the mean and median for, let me go to the end of this. You're going to look at the 5-number summary and a box plot for these boys times and girls times. So first I'm going to do the running times as L3 data of, and then I put of the gender column and then a run time. So this run data frame, if you want to look at it, you can just run after it. This will show you each entry and then for their different run times. So now if I want to do the next thing, I'm going to do run and group it by gender and then print out the descriptive statistics. So in looking at this, boys have a faster runtime than girls. And then here, the median runtime for girls is 62 seconds for the 400-meter dash, and this is 55 seconds for boys. And then we can create a box plot, which we see here, the boys, the median runtime is 55 seconds with some really, really fast boys up there. And then here, the girls' time, the median runtime is above 60. And then these are girls that are taking faster or longer to run those times. And that concludes our lesson.